last bit of chapter 13. I am going to combine a little bit of chapter 12 in here as well, but we're going to talk about buffers and our bodies. So for those of you, especially who are going into nursing, this is going to be important, or any health field really. But this is how our body buffers our blood, and what happens when there's a shift in equilibrium, right? Le Chatelier's principle, which we just talked about. First of all, what is a buffer? A buffer is a solution that can maintain or withstand changes in pH by neutralizing small amount of added or base, extra added acid or base. Right? So if we take a look over here, we have just pure water. And if we add, it's at 7, a pH of 7, because it's pure water. If we add some base to it, look at how large of a pH change. So 3.5, right? It becomes very basic very quickly. If we add some acid to the pure water, pH drops to 4. So we have a huge change of pH from pure water because it's not buffered. To have a buffer, we must have an acid, a weak acid, and its conjugate base. Remember, we talked about acids and conjugate bases in chapter 12. But if we have an acid, it can react with some of that OH that is added, and it doesn't affect, so it increases the pH a little bit, but not by much. And if I have an added base, or the conjugate base of this acid, that base can react with the added acid. So if I add some extraneous acid to that, my conjugate base of the original acid in the buffer can react with that, and the pH doesn't drop so much, just a little bit. So look at how little, for the same amount of added extraneous acid or base, how little the pH changes versus this system here where I have only pure water. So buffers work because they resist changes in pH. In our body, they absorb these extra H3O plus or OH minus ions that are formed from foods, breakdown, or cellular processes, and they maintain the pH. It's important to maintain the pH because many proteins function at certain pHs, and if the pH changes too much, then our proteins in our cells they start to break down, and our cells are not going to be able to function properly. Our blood pH has to be maintained to 7.4. If we go too much beyond this, our body is in an alarm state because it causes so many issues. We enter what is called an acidosis or alkalosis state. So acidosis is when the blood pH drops, right? It gets less than 7.4. Alkalosis is when it increases, and we cannot go too far beyond the 7.4 value here. So changing the pH of the blood obviously affects the uptake of oxygen and other cellular processes, and it affects our body function. It could even kill us depending on how far we deviate from this value. As I mentioned, the components of the buffer solution, it has to have equal concentrations of a weak acid and its conjugate base, its salt, conjugate base of my weak acid. I picked this one to show you because this is what our body uses, and we're going to talk about in the context of our blood buffer system. Now, it's not the only buffer in our body, but it is one of the main ones. So the important thing to remember about a buffer solution is that it has to have equal concentrations of a weak acid and its salt, its conjugate base, and large amounts of weak acids and the conjugate base. So in the buffer with carbonic acid and sodium bicarbonate, now this isn't that important, but the bicarbonate ion is. The salt will produce bicarbonate ions and sodium ions. And so basically the salt is just added to provide the higher concentration of the bicarbonate. So my acid dissociates a little bit into its conjugate base and hydronium ions. So I add some extra HCO3 from this salt to make sure that I have equal concentrations of this acid and its conjugate base. So how does it function? Well, if this is, so I have a weak acid and its conjugate base in equal concentrations. Well, what happens when I add some extra OH to this system? Well, the OH is going to react with the acid to produce the bicarbonate and water. And a little bit of my H2CO3 is going to be used up, so its concentration goes down a little bit. But this reaction is going to produce some more bicarbonate, so this concentration is going to go up a little bit. Now, it's not going to go to change by a whole lot, right? But this is how those extra OH minus ions are absorbed, and they don't change the pH of the blood so much because they react with a carbonic acid, producing a little bit of more of bicarbonate, and the carbonic acid goes down a little bit. But if I have, if I have the acid here, right, I have H2CO3 and HCO3 minus in equal concentrations. What happens if I add acid to that system? Well, if I add acid, that is going to react with a bicarbonate ion to produce carbonic acid. So the concentration of HCO3 minus goes down a little bit and H2CO3 goes up a little bit, right? So it's the opposite effect. Now, if I started not with equal concentrations, but where we left off with the OH minus after we added the extra OH minus, so we had an increase in HCO3 and a decrease in H2CO3. But if to that same system we add H3O plus, like we do here, we go back to the equal concentrations, right? Because the H3O plus is going to react with the excess HCO3 minus and produce H2CO3. So you can see how there's, if we add OH minus, that's going to increase this and decrease that. But if we add H3O plus, it's going to have the opposite effect. So the H2CO3 and HCO3 minus are going to stay kind of constant in our body because we're going to have, they're going to absorb both the H3O plus and the OH minus concentrations. Now let's talk a little bit about what happens when we have acidosis or alkalosis. Acidosis, as we said, is when we have too much H plus or H3O plus in our blood. Alkalosis is when we have too little, okay? Well, what happens when a person is, let's say, hyperventilating, okay? What does hyperventilation mean? Well, we're rapidly breathing. So when we're rapidly breathing, we're expelling too much CO2, right? So now we're going to apply Le Chatelier's principle as well to this system. But here's those reactions that tie in together, right? CO2 plus H2O gives H2CO3, which in turn can break down to H plus or H3O plus and HCO3 minus. So these are linked together. So the concentration of CO2, whether it increases or decreases, is going to shift these equilibria, right, and affect the pH of my blood. So let's take a look at what happens when we expel too much CO2. but during hyperventilation? Well, CO2 concentration goes down, which means that our body or this reaction is going to shift in the direction that is going to make more, right? We introduce the change, which is getting rid of CO2, too much of it. Because we're getting rid of it, our body's going to try to make more. So all of these reactions are going to shift in, so the reverse reaction or to the left, which means that I am going to decrease the concentration of H plus in my blood, which means decreased concentration of H plus means alkalosis. And we run the risk of alkalosis of the blood when we're hyperventilating. And what do we tell people that are hyperventilating? We say breathe into a bag. Why is that? Well, because by breathing into a bag, they can rebreathe some of the CO2. And the concentration of CO2 goes back up, shifting then to the right, and that adjusts the H plus level. Okay, what happens when we take shallow breaths? We don't breathe deeply enough. Well, if we take too shallow breaths, we're not getting rid of CO2 like we should, meaning that the concentration of CO2 is too high. And our body is going to obey Le Chatelier's principle. It's going to shift the equilibrium towards the right to try to get rid of that extra CO2 that we're not getting rid of by breathing. As it shifts to the right, it's going to make more H plus ions or H3O plus. Higher concentration of H3O plus, hydronium ions, means acidosis, a lower pH. So acidosis of the blood. Our body doesn't like that either. And then we tell people to stop and take deep breaths. And as I take deep breaths, we get rid of that extra CO2 buildup and the equilibrium shifts back towards the left and we get rid of that H plus. Now, this is, we control the H plus concentration by breathing because it's linked to the CO2, but our kidneys can control the HCO3 minus concentration. Now, this is a lot slower, but because it has to make it through, it has to get filtered through the urine. But you can see that our kidneys can either lower the concentration of H3O minus by getting rid of it in urine, or hold on to it, reabsorb it back into our blood if we have too little of it. So there are two ways for our body to control the buffer system. And it's beautiful once again because we need all of these checks, if you will, in place because our pH cannot deviate much from the 7.4. And that is how our body deals with either the H3O plus buildup or lack of, or the HCO3 minus. And Le Chatelier's principle helps to shift these reactions to the left or to the right, depending on what the situation might be. This is important for those of you who are going into the health field. It's important for you to remember and to learn because you will have to deal with patients who either have acidosis or alkalosis of the blood.